Good evening, everyone, and welcome to the virtual public informational meeting for CTDOT project number 77-248, replacement of bridge number 05353 in the town of Mansfield. The project contact information is shown below, and this will be a live Zoom event. Next slide, please. This is a quick slide on how to use closed captioning and subtitles in Zoom. In the taskbar below, there should be a button for clicking to show closed captions, and you can select the speaking language and select which language you would like to have from the list shown. Closed captioning, including non-English translation options, are available on YouTube after the event. The goals for tonight's meeting will be some general housekeeping items, a formal presentation of the design, which will include explaining the existing conditions and definition of the purpose and need of the project, as well as our proposed recommendations. Following that, we'll have a live Q&A session to answer any questions that you may have. This slide I'll read on Title VI, Civil Rights. No person shall on the basis of race, color, or national origin be excluded from participation or subject to discrimination in the development of this project. We highly encourage you to fill out the voluntary post-meeting survey located at the hyperlink and QR code as shown. There's also a link to our Title VI Office of Equity Division regarding civil rights. A recording of this presentation will be posted to YouTube after the event, and closed captioning, including non-English translation options, are available on Zoom and YouTube. Here's another slide regarding Title VI, Notice to the Public and Civil Rights. And the same slide in Spanish. And to use the Zoom Q&A, there's a button below on the taskbar to select the Q&A tool, and then you'll be able to type your question in there, and then type your question in the text box and click enter. If you're using audio only, please dial *9 to raise and lower your hand. You can also reach out to us by email at dot-flbp@ct.gov, by phone at 860-594-2020, which is a monitored voicemail line, and through the Zoom Q&A chat. We also encourage you to visit the project webpage, and the comment period is open for the 2 weeks following the event. However, the Zoom Q&A is only available during the live Zoom. Funding for this project is through the Federal Local Bridge Program under the Design Managed by State, or DMS program. In the past, the Federal Local Bridge Program was funded at an 80% federal and 20% town match for design, rights-of-way, and construction. Under DMS and through the Infrastructure Act, design, rights-of-way, and construction phases are all funded with a minimum of 80% federal and a maximum of 20% state funds. Design, rights-of-way, and construction phases are at zero cost to the town. And even though the department is taking on design on behalf of the town, it is still a full partnership and coordination with the town, and we are hearing all their concerns and incorporating them into the design where applicable. The goals of the DMS program were to provide a streamlined approach to design using full DOT resources, to aid towns in keeping their structures in a state of good repair by effectively using funds, decrease typical design time from 60 months plus to 24 to 36 months, and when applicable, to utilize accelerated bridge construction techniques, or ABC techniques, to shorten construction duration, and to increase the number of municipal projects delivered to construction each year. Now introduce the project team from the Department of Transportation. Our division chief is Bart Sweeney. Derek Lassard is the principal engineer of the CLE group, which is consultant liaison engineer. I'm Mark Burns, supervising engineer for the local bridge program. Michelle Rame is the project engineer, and Zach Arino represents the Office of Rights-of-Way. Representing our consultant liaison, Clough Harbor and Associates, is Anand Sasadri, CLE team leader, and Tom Sawtell, CLE project manager. This is a quick slide showing the key structural elements of a bridge. Carrying the traveling on the top is the deck, which carries vehicles, pedestrians, bicycles, etc. Protecting those people are the parapets. Supporting the deck and parapet is the bridge superstructure. In the case of this diagram, is made from steel beams. Supporting the remainder of the superstructure and deck is the abutments or substructure. Also in this slide, you'll see wing walls that act as earth retention. And depending on the length of the bridge, there could be one or more piers, or if it's shorter length, there won't be any piers. Bridges are rated on a condition scale of 1 to 9, with 9 being in excellent condition and 1 being an imminent failure. But don't let that be a concern, because if there was ever an issue with a bridge, our Office of Bridge Safety will alert the town immediately to take corrective action. Here's some quick examples of some different types of concrete deterioration. Efflorescence is a chemical reaction when the chemicals inside concrete react and then create that white substance you'll see on the surface of concrete. Honeycombing is a result of improper setup when a concrete form is made, and then when the forms are stripped, that will happen with different voids. Scaling is as a result of freeze thaw, as well as map cracking from wear and tear. And then a more severe case of honeycombing is spalling, where freeze thaw has occurred so badly that the concrete is exposed to the rebar. I'll now quick turn it over to John Carrington, Director of Public Works from the town of Mansfield, for some brief remarks. John?
Thank you, Mark. I'd like to welcome everybody to this meeting. We're very excited to be working with the Department of Transportation and CHA engineers to get this done. Tonight, if you have questions, please address them only on this bridge project. We were in the neighborhood doing some paving. If you have any issues with that, please just call my office at Public Works. And I'd like to point out, even though it's been addressed, that the town is not paying for this project. The state is picking up where the town usually pays the 20%. So if you pay federal or state taxes, your tax dollars are coming back to your neighborhood to take care of your bridge. Thank you.
Thank you, John. I'll now turn over to Tom Sawtelle for the formal presentation. Tom?
Thank you very much for the introduction, Mark. Good evening, everybody, and thanks for attending tonight's meeting. First, just want to say that I'm very excited to present on tonight's project, particularly because I graduated E.O. Smith in 2015 and graduated UConn in 2019, and I've been a resident of Mansfield my entire life. So it's very exciting to be working on a project that's so close to home. So to start off tonight, Bridge 5353 is highlighted here in orange in this project location map. And the bridge is situated between the intersection of Juniper Lane and Route 89 to the west, approximately 150 feet. And the intersection of Juniper Lane with Brookside Lane, approximately 300 feet to the east. The bridge currently carries bidirectional traffic over the Mount Hope River, and the Mount Hope River flows from north to south under the bridge, or top of the page to bottom of the page, as you're seeing on your screen here. So speaking to Juniper Lane and the geometry that's out there today, the roadway consists of 2 travel lanes, and Juniper Lane's curb-to-curb width is 18 feet 8 inches at the bridge today, and that's currently substandard. So that's the first thing that I'd like to highlight that's an issue with the bridge that's out there today. The second thing is that the north and south legs of the Y intersection, which is located west of the bridge, have a width out there today of 14 to 16 feet, and they currently carry bidirectional traffic. That's another portion that's substandard. Those widths are too narrow to carry the bidirectional traffic out there today. For the bridge width itself, given the ADT that's on this road, the feds specify a 20-foot minimum curb-to-curb width. And For Connecticut DOT standards, the minimum is 18 feet, but the preference is to have a 24-foot curb-to-curb roadway width. The ADT over this road was 291 vehicles based on traffic counts that were collected in August of 2023. From those traffic counts, we got an 85th percentile speed of 24 miles an hour. Now, today, the road is currently not posted for any speed limits. So we assumed that just looking at the bridge and the geometry that's out there today, that, you know, it's probably a 25-mile-an-hour road. So because of that assumption, we went with a design speed of 25 miles an hour for this project. The last thing that I'll point out as well is that Juniper Lane is classified as a rural local road. The photos that you can see on this slide to the left just show the road looking over the bridge facing to the east towards the intersection of Brookside Lane. And then the photos on the right show the south and north legs of the Y intersection respectively. So the existing bridge was originally constructed in 1920, making it 104 years old. The bridge was rehabbed in 1986, and that work consisted of a superstructure replacement and substructure repairs. The bridge is a single span bridge, as you can see on this photo to the left, and the span length, or the distance between faces of abutments, is 39 feet 6 inches. The bridge consists of a superstructure with 6 15-inch deep pre-stressed concrete deck units, a substructure that's 11.5 feet high, stone masonry abutments with concrete bridge seats, as you can see here in the photo, as well as the stone masonry abutments with shotcrete facing below. The foundation type is unknown due to the lack of as-built plans that exist for the bridge. And that foundation is below the water line, so you can't really see it in this photo anyways. The next issue that I want to highlight is that the bridge is currently hydraulically inadequate for the 100-year design storm. This bridge is classified as a large structure because it's got a 35 square mile watershed. And today, the 33-foot clear span opening of the bridge is less than 37 feet, which is less than the 1.2 times bank full width of the Mount Hope River. Additionally, we've got 4.9 feet of backwater, which is greater than the 1 foot maximum standards. The backwater is defined as the difference in the water surface elevation upstream of the bridge. And it's a comparison of the water surface with the bridge that's in place today compared to the natural condition if you were to remove the bridge entirely out of the stream itself. Additionally, we have negative 3.4 feet of underclearance for that 100-year design storm. So essentially, the water is above the bridge and the roadway surface on the bridge today by about 3.4 feet. And then also we've got negative 2 feet of freeboard, and the freeboard is defined as the distance between the low point of the roadway, which is a bit off the bridge, to that water surface elevation for that design storm. The last thing that I'll point out is that the bridge is scour susceptible, meaning that the scour depths can go below the bottom of the foundation of the existing bridge. So the bridge was last inspected in March of 2022 by Connecticut DOT. And based on that latest inspection report, we found that the deck's in fair condition, the superstructure is in fair condition, the substructure is in good condition, the approaches are in satisfactory condition, and the channel and channel protection is in good condition rating. The photo here on the left is just a northern inlet elevation of the existing bridge today. So Connecticut DOT performed a load rating in March of 2021 on this structure. And from their analysis, they found that the inventory HL93 truck rating is a 0.53, which is less than the 1.0 minimum, making it substandard. So that's another major issue that I want to point out with this bridge tonight. Additionally, they found that AASHTO and CT legal load ratings, several of them are below a 1.0. And because of that, the bridge is currently posted for a 26 ton weight restriction at both approaches to the bridge on Juniper Lane. So the next couple slides are just some photos of the existing bridge and surrounding roadway and site conditions. These are based on photos that we took out there in the field in the springtime of last year. So in the top left, you can see we've got the south outlet elevation of the bridge. The top right is the north inlet elevation view of the bridge. The bottom left is the bridge looking west, or from the west approach, essentially standing at the Y intersection between Juniper Lane and Route 89. And the bottom right photo is the bridge looking east towards that Y intersection, sort of in the other direction here. And I want to point out that these two red arrows are pointing to overhead utilities, which currently exist and run along the south fascia of the bridge today. So the top left photo is looking west over the bridge. It's a closer shot. And as I mentioned, you can see the weight limit posting sign here at this approach. The top right photo is just a view of the Y intersection right after the bridge. The bottom left photo is the south leg of Juniper Lane looking west towards Route 89. And again, you can see that posting sign here. And then the bottom right photo is the north leg of Juniper Lane looking west towards Route 89. And in this photo, again, here's the weight posting sign, as well as you can see there's some impact to the existing approach guide rail, as I'm highlighting here. The top left photo is a condition of the existing bridge rail system that's out there today. The top right photo is the northwest and southwest approach rail systems. Again, you can see the impact in this left photo. And then I just want to point out that the rail posts have some spalling right at the base, where the bases connect with the approach here. The bottom left photo is just a view of the condition of the bituminous overlay over the bridge. Overall, it's in really pretty nice shape, as you can see. And then the bottom right photo is a shot looking underneath the bridge, looking up at the pre-stressed concrete deck units underneath. The top left photo and right photo are the east and west masonry abutments with the shotcrete facing and the concrete caps, as I've previously mentioned. And then the bottom left and bottom right photos are just showing the existing stone masonry wing walls that are out there today at all four corners of the bridge. The top left photo is a view of the Mount Hope River looking upstream of the bridge. The top right photo is a view of the Mount Hope River looking downstream from the bridge. The bottom left photo is just a view of the intersection of Brookside Lane and Juniper Lane. This is looking south, heading towards Atwoodville and Elizabeth Road. And then the bottom right photo is just an example of the lack of drainage that's out there today and closed drainage systems at both approaches. As you can see, there's a paved leak-off pad, and that's present at all four corners of the bridge. So as I've mentioned here in the presentation so far tonight, the bridge and surrounding site have some obvious issues, and the purpose of the project is to address the issues with the bridge. We want to increase the load carrying capacity of the bridge and eliminate the weight restrictions that are out there today. We also want to increase the substandard roadway width to a 24-foot curb-to-curb width over the bridge to meet current state and federal standards. We'd like to eliminate the scour deficiency that's out there today with the foundation. We'd also like to replace the bridge and approach rail systems to meet current safety standards. We'd like a new bridge that'll improve the hydraulic performance at the site. And then finally, as I mentioned, the bridge is very old. The superstructure is 38 years old, and the substructure is over 102 years old. So because of these reasons, we're going with a full bridge replacement as part of this project. And I also just want to point out and reiterate what Mark said, that despite the deficiencies that exist with this bridge today, the bridge is safe for the traveling public still because it's inspected on a regular basis by Connecticut DOT. So for the new bridge, we're going with a pre-stressed concrete deck unit bridge. The photo here on the right is just a sample of what a pre-stressed concrete deck unit bridge will look like. This was a job that was recently completed in the summer of this year. So with this new bridge, we're going to be able to carry all of our AASHTO design, legal, and permit vehicles and eliminate that weight restriction that's out there today. We're also going to be able to accommodate that wider 24-foot roadway width. And with a brand new bridge, we'll be able to have a new foundation that'll be designed for scour. The new structure will be designed for a 75-year service life and require minimal future maintenance. And then also we're going with open bridge rail and approach rail systems that will meet current safety standards. And then finally, I just want to point out that we're going to be improving the roadway drainage around the bridge site. Now, with this new bridge, we're going to be making some significant hydraulic performance improvements. We're going to be widening the span of the bridge out to 50 feet of clear span that will meet the 1.2 times bank width of the channel. We're also going to be improving the hydraulic underclearance to 1.6 feet. We're also going to be reducing that freeboard and eliminating that roadway overtopping condition that exists today for the design storm. And then finally, we're going to be reducing the backwater elevation to 1.8 feet, which is a significant improvement from the 4.9 feet that's out there today with the existing bridge. The last thing that I want to point out is that with this new bridge, we're going to be improving the aesthetics. So we're going to be going with a form liner applied to the concrete, which will simulate masonry stones. And that's going to be on the end blocks, wing walls, and exposed portions of the abutments of the bridge. I've got two photos here, the one in the bottom and the one on the right side of the screen here. You can see these are just two examples of potential form liner colors and shapes of the stones that were used on a couple of recent bridge projects. Second, we're going to be metallizing the bridge rail to the town's color choice. These photos just show a black metallized 3-tube curb bridge rail. But again, it'll be up to the town as the design progresses to choose that color. So the next couple slides are some of the conceptual plans for the project and for the proposed bridge. So to start out, here's a proposed bridge cross section. This is looking east along the bridge. And as you can see, the new bridge is going to accommodate that 24-foot widened curb-to-curb width and two 12-foot wide travel lanes. The superstructure will consist of 3 inches minimum of bituminous concrete overlay, a 6-inch minimum cast-in-place concrete deck, and 1 foot 6-inch deep pre-stressed concrete deck units for the superstructure. So here's a bridge plan of the proposed bridge. Just to orient everybody real quick, we're looking from west to east along Juniper Lane. The limits of the proposed bridge are highlighted out in orange. And as you can see, we're going to be widening the clear span of the bridge. And the overall span length is going to be widened to 53 feet, which will provide us that 50-foot clear span that we want. To accommodate the widening, that the westerly abutment will be reconstructed approximately in the same location that's out there today. And the easterly abutment will be moved further to the east to accommodate that widening. Other features that I want to point out, in gray, we have highlighted the proposed wing walls and retaining walls. So on the west side, for the inside corners of each of these legs of Juniper Lane, we have U-shaped wing walls coming off the bridge and curved retaining walls that'll help to retain some of these embankment fills. On the east side, we're going with flared wing walls, as you can see here. And then the last thing that I just want to point out as well, like I mentioned, we're going to be improving the drainage at both approaches to the bridge. So we've got new closed drainage structures on the west side and east side. They're going to be installed as part of this project. The last thing that I want to mention too is I talked about the overhead utilities which currently exist on the south side of the existing bridge. For the new construction and to install the new beams, we're going to be using cranes and working out there, and the overhead utilities are going to need to get relocated further to the south temporarily, as I'm showing here, highlighting with my pointer. There's an elevation view of the proposed bridge. So this is a south elevation looking at the bridge, or looking at the downstream side, looking up. And again, we've got the widened 53-foot span length. And then we're also showing the simulated stone masonry on all exposed surfaces of the substructure. So that's the wing walls, the end blocks, and the parapets for the curved retaining walls going up along the two legs of the Y intersection. The other thing I'll point out is that on the west side, the foundation that we're going with is a spread footing that will be founded on competent bedrock. And on the east side, we're going with a micropile foundation that will be socketed to bedrock. Both of these foundations will be designed for scour. So here is the proposed roadway plan. And again, just to orient everybody, we've got Route 89 to the west as I'm pointing in the screen. And then you're continuing on with the Y intersection through Juniper Lane to the east, and till you hit the intersection with Brookside Lane on the right-hand side of the screen here. The yellow is pointing out the limits of the roadway reconstruction that will be included as part of this project. We have approximately 600 feet of roadway reconstruction, and that'll be full depth pavement reconstruction along Juniper Lane as part of this project on both sides of the new bridge. Now, as I mentioned, we're going to be talking about this Y intersection tonight, and we're making some significant improvements to the Y intersection as part of this project. The first thing that I want to point out is today both legs of the intersection operate in a bi-directional way, meaning that traffic can go in and out on either leg as they wish. So when we looked at this project and we looked at the widths that are existing and out there today, looked at where the rights of way are and where you have to grade out to improve the vertical alignment of both of these legs. We also talked to the town and the state on this a bit, and the sense was to change the orientation of the Y intersection from bidirectional on both legs to a one-way in on the south leg and a one-way out operation on the north leg, as well as narrowing up the legs to 12-foot widths as part of this project. The other thing that we're going to be doing is at the intersection with 89 for both of these legs, we're teeing up the legs to 89 and performing some clearing and grubbing operations in the area between 89 and the Y intersection. And that's to improve sight lines for users coming in and out of the Juniper Lane once the project's completed. The next thing that I want to point out is that, as I mentioned, we've got the drainage out here, and the town's been out here actively in the last couple of months installing drainage between Brookside Lane and the bridge. And we're going to be tying our drainage in with the town drainage as part of this project, as I'm showing here. Then it's a little bit hard to see, but you can take my word for it. We're also proposing new guide rail at all four corners of the bridge and approaches that will meet current safety standards. And those are highlighted out in like the magenta pink line work, as I'm trying to point out here with the pointer here on the map. So here is a roadway profile. So this is the south leg of the Y intersection with Juniper Lane also tied in. So, you know, if you're looking on the left-hand side of the screen, this is where Route 89 would be. And then you've got the south leg proposed. The bridge, again, highlighted out in orange. And then continuing on Juniper Lane till you hit the right side of the screen. This would be where the intersection with Juniper Lane and Brookside Lane would be located. As you can see, we're raising the roadway profile up approximately 3 feet at both approaches. And the reason why we're doing that is to improve the existing curve geometry and also lessen the slopes that are out there today for both of the Y intersection legs. Right now, today, they're very steep slopes, and we wanted to get them up to the current design standards. Then similarly, here's the profile for the north leg. So again, it's the same profile, it's just that this portion of the profile is for the north proposed Y intersection leg. So for this project, we're going to be going with a full detour and closure of Bridge 5353 to construct the new bridge and work on all of the paving and roadway reconstruction operations at both approaches. Now, depending on how construction goes, or design goes, because this job is currently in design, along with the bridge to the south on Atwoodville Road, as I'm showing here with my pointer. We're actively in design, still working through the permit process, rights-of-way acquisitions, and getting the jobs in a good enough state for plans and specs to be able to bid them. It's too far out to tell how these jobs are going to go out into construction, but one of two scenarios is going to happen. The first scenario potentially would be that Juniper Lane goes into construction 1 year, and then Atwoodville Road goes into construction on a second year or the year after. If that happens, then the detour route, which is 2.2 miles long, as you can see on the left-hand side of the screen, will be able to be used by passenger vehicle traffic throughout the road closure. And then on the right-hand side of the screen, trucks will be able to use the longer southerly detour route, which is about 8.5 miles long. If both bridges end up going into construction in the same season, and they both end up being out of operation for a construction season, then ultimately that's the southerly detour route will have to be used to accommodate vehicle users through both of these project sites. And that's, again, the longer detour route that I'm showing here on the right-hand side of the screen. So, as I mentioned, we've got overhead utilities, and those are going to need to be temporarily relocated and maintained throughout construction. Further to the south, they'll ultimately get relocated back approximately to where they are out along the roadway today. We've also got some environmental impacts. There's going to be some tree clearing along the roadway. There's some temporary and permanent wetland and watercourse impacts as part of this project to install the bridge, the new abutments, perform the grading at both approaches. We're going to be using best management practices for fish and wildlife in the Mount Hope River. And the last thing that I want to mention is that we're going to be providing for a pull-off parking area for fishing and recreational activities around the bridge as part of this project. For historic impacts, there's no historic impacts anticipated around the site. The bridge is also not considered to be historic, and we've already completed a phase 1 archaeological investigation. For anticipated permits, we're expecting a Town of Mansfield inland wetland permit, CT Deep flood management certification, and then a U.S. Army Corps of Engineering self-verification. So here is a slide where I'm just going to highlight through the rights-of-way impacts at all 3 of the adjacent properties surrounding the project limits. On the north side here, we mainly have some rights to grade as well as rights to install sedimentation control systems such as a sedimentation fence, and then also a right to remove and then ultimately reconstruct a portion of the stone wall that's outside of the town's right of way, which is shown currently and highlighted in this red line here. The property to the southwest, down here, it has a few more impacts. First thing is that we're going to need a permanent take to accommodate the new curved retaining wall and embankment slopes for the newly reconstructed south leg of Juniper Lane, and then also for the parking pull-off pad that we want to add along the south leg as well. Additionally, we've got one drainage right-of-way that we're going to need for the outlet protection and pipe that we're going to be putting in for the new drainage that's located to the west of the bridge. And we've also got a temporary construction easement to accommodate that temporary overhead aerial utility move that's going to the south during construction. The southeast property here, we have a permanent take to accommodate the flared wing wall that we're going to be putting in with the new bridge, as well as a temporary construction easement for the temporary overhead utilities. And then the other thing that I'll point out with this property is that we're going to be reconstructing a portion of the driveway and apron. And then also we're going to need that right to remove and reconstruct a portion of the stone wall that's immediately adjacent to the driveway. The last thing I want to mention too is that the property to the north, there is an access, if you will, to the backside of the property. We're going to be paving and defining that apron, as you can see in the highlighted black region here, just to establish that access and then also to protect the roadway in the final condition when traffic needs to go over that for access to the backside of that property. And I'll pass this off to Zach, who's going to explain the rights-of-way process.
Thanks, Tom. My name is Zachary Garino, and I'm a project coordinator with the Department's Division of Rights-of-Way. Our office is responsible for acquiring the property rights needed for transportation projects. As Tom mentioned in the presentation, this project will require the acquisition of property rights, so I'd like to give a brief overview of our acquisition process. Before I begin, I'd like to mention that the specific impacts are still being finalized, and they may change as the design progresses, and that any required property rights will be acquired in accordance with Connecticut General Statute Sections 13A 73 and 13A 98E, as well as the Uniform Act. As Tom mentioned, we have partial takes, which are fee takings. We have the permanent easements as well as temporary construction easements. You can change the slide. So the right-of-way acquisition process begins once the design has progressed to a development milestone and all the impacts have been determined. At this point, each affected property owner will receive a formal letter of intent to acquire from our office, along with a property map which depicts the exact property rights to be acquired. And on the screen here is an example of a property map that an owner may receive. It shows the proposed conditions as well as the existing conditions. So next, our office is going to determine the fair market value of the property rights which were depicted on that map, and we'll use it to establish an offer of just compensation. That offer will be sent out to the property owner in writing, and a right-of-way agent will be available to meet with the property owner and explain the project, go over the specific impacts to their property, and explain how the state arrived at its offer. The property owner will be given a reasonable amount of time, typically 30 days, to consider the state's offer and enter into negotiations. When an agreement is reached, the department will prepare all the necessary paperwork to record the deed and property map on the town land records. However, if an agreement cannot be reached, in order to keep on schedule, the department may acquire the necessary property rights through its power of eminent domain. In that event, the state files a notice of condemnation in the Superior Court, along with a monetary deposit in the amount of the state's offer. The owner would have 6 months from that date to file an appeal if they felt that the state's offer was inadequate. Whether or not the owner chooses to appeal, the money deposited in the court is available to be withdrawn by the owner. And it's important to note that the state only acquires property rights that are needed for this specific project. If there are any questions regarding the right-of-way acquisition process, I can answer them after the presentation. With that, I'll hand it back to Tom. Thank you.
Thanks, Zach. So this project is currently anticipated to start construction in the spring of 2027. And as I mentioned, this job, as well as the job to the south on Atwoodville Road, are currently in the design process and phase. And this is subject to right-of-way and permit approvals, of course. The construction duration that we're anticipating is 1 season or approximately 8 months. And the construction cost estimate for this job is $4,550,000. That's an 80% federal fund and 20% state fund split. And as Mark and John have mentioned previously, this job is coming at no cost to the town. And just want to note that the cost and schedule are preliminary and of course subject to change as the project progresses. Thank you very much.
Thanks, Tom. Thanks, everyone. We're going to now move on to our live question and answer session. I just want to let you all know that you can ask your questions by submitting them to our email, which is dot-flbp@ct.gov, or you can call us at 860-594-2020 and leave us a voicemail, or you can ask us right now during our live Q&A chat by entering them into our chat. You can get information on this project at our project webpage, which I have posted in the chat a few times. As of right now, we have no questions, but feel free to ask us anything. Oh, and the comment period is open until October 29th this year. You can do those questions through the email or the voicemail up until that period as well. Okay, we just received our first question. Has the state considered a full acquisition of the property to the south of Juniper Lane, west of the river and east of Route 89? This property currently has no legal description, I believe.
Want me to take a stab at that one?
Sure, please, Zach. Thanks.
Yeah. I mean, I guess that's something we could look into, but the general principle is that we only buy what we need for the project. So unless there's like a real need to facilitate a larger acquisition, we wouldn't typically do that just for the sake of trying to like clean up an area. But it's something we could look at in terms of maybe trying to increase the acquisition area on the corner. But we haven't done a title search yet to identify the whole parcel. So when we do our title search, we'll get a better understanding of the actual dimensions and how big it is and the ownership and everything related to that. But the general principle is that we don't acquire what we don't need for a project. Thank you.
Thanks so much, Zach. Again, our comment period is open until October 29th. So if you don't have any questions tonight, but if you think of something before that period, you can send it to our email, dot-flbp@ct.gov, or you can leave us a voicemail at 860-594-2020. If you do think of one in the next few minutes, we'll stay here for our live chat. I did just get another question. Andrew Berry would like to ask, why is the lion's share of the acquired property from 14 Juniper Lane?
Want me to start with that one again, or somebody else want to start? I'll just take the first stab here. Yeah,
Go
thanks
ahead,
for your
Gary.
question, Andrew. As you can see, the right-of-way line is really what's really driving this here. To the north side is a lot wider, so the bridge is closer to the south, where the right-of-way is. So that's really the major reason why most of the impacts are to the south, and specifically on your property, we have the wing wall, hence why we need to take. But it's really the right-of-way and where the road and the bridge sit within that is really causing the impact to the south side.
And this is Anand from CHA. And all I wanted to add was, as Tom defined early on in the presentation, there was a certain purpose and need for the project. So the bridge that was present today was not adequate, both in terms of the roadway width or the hydraulics. And so we had to make the bridge a little longer and wider. And so with the right-of-way lines where it is, the impact is more on the southerly side of the bridge.
Thank you, Zach and Anand. Right now, we have no further questions, but we'll give it a few more minutes. No problem. Thank you, Andrew, for your question. I am going to put the project webpage in the chat again for anybody who would like to keep up to date on information. We did get another question. Will the new slope of the Y intersection west of the new bridge be adequate to accommodate trucks with trailers? Currently, some trucks and trailers scrape the road due to the change in the pitch.
Jeff, would you like to address that?
Yeah, sorry about that. I was trying to get my camera to come on. Good question. As Tom mentioned, and we're looking at the profile right now, by raising the bridge, we're actually decreasing the steepness of the road from the bridge up to Route 89, which is going to improve, I think, the condition that you're talking about, where a truck with a trailer leaves the bridge and goes up that steep slope, and as a result, the trailer and the truck kind of bend in half, and the trailer winds up hitting the road. But we're putting a much bigger vertical curve in here, and you can see with the green area there, that's the area that we're going to be filling from the proposed road surface down to the existing. So we're making it a much smoother curve. So answer to your question, no, trailers and trucks would not scrape the pavement. It would eliminate that condition.
Andrew made a comment. He said, so the reason is because the earth below the south side of the current bridge is stronger than the north side.
Is this, I'm not sure which question this is in reference to.
I'm not sure.
I think it's in reference to the reason why there was the impact of retaining wall, or the wing wall rather, on the south side. I mean, I don't think necessarily true what he's saying, like why it's on that side. I don't know if you want to add to that, but that's the context I think he's asking it in.
Well,
the south.
Yeah, I can tell you, why didn't we go to the north? Maybe is kind of the question.
Yeah.
If you look at the Y intersection, we're trying to maintain a balance on that Y intersection. So the south leg and the north leg are basically the same length. And it pretty much matches existing. If we were to shift this bridge north, we're going to shorten that north leg of the Y intersection considerably. And that's going to create a much steeper condition. It's going to make us more difficult for us to create a level landing at the top at Route 89. So really balancing the two legs of the Y intersection is kind of where the alignment ended up. So there is a little bit more impact on the south side.
He said thank you. He understands now.
Great.
Okay, perfect. Another question. Currently, many vehicles enter Route 89 from the northerly leg of the road due to better sight lines. The angle to turn left onto Route 89 at this area is very difficult to enter Route 89. Will there be more space provided to provide a safer entry onto Route 89?
Sure, I could take this one again. So as Tom mentioned, we are squaring up this intersection a little bit more. The intersection that was there was really skewed. So it makes it more difficult to turn left. We still want to make some more improvements to what you see here. But in terms of the way it operates now, you will see some improvement with the current design. But again, there's still more design to do. And if we can improve the turning movements even more, then we're going to do that. We actually had a conversation with DOT traffic. Since this is a state road, this gets a little more review than your typical, let's say, town road. So we will have some more meetings to discuss turning movements and sight distances out of both of these intersections. Good question.
So much, Jeff. Great questions, everybody. We currently don't have any further questions at this moment. We'll give it a few more minutes. If you think of anything, the comment period, like I said, is open until October 29th. And you can send any further questions to our email at dot-flbp@ct.gov or to our voicemail at 860-594-2020. Oh, here we go. Did you consider a longer bridge span in order to eliminate the Y split altogether?
I can take this one again. So early on, as we were getting into this project, we did have conversations with the town, and this intersection was brought up early on. One of the things we looked at was connecting, let's say, the bridge straight to Route 89, and I think that's kind of what the question refers to. The elevation difference between where the bridge is and Route 89 is quite different in vertical elevation. So in order to get a roadway to go from the bridge to Route 89, you'd end up with a 20% roadway grade, which is far exceeds what the allowable grade is for this type of roadway. So we did look at that, but it's physically impossible to get that to work.
Thanks, Jeff. Kurt said, thank you for taking the time to provide all of that information.
Thanks for the comment, Kurt.
I have another question. Is it true that there will be one-way traffic once complete? I mean, only one leg will be an entrance and exit to the north and the same to the south.
Yeah, that's
I could-
correct. So are
that's
you going to take
correct.
that, Tom?
Yeah, I can take that.
Okay,
So,
sure.
as I mentioned in the presentation before, the south leg is going to be a one-way in to head on to Juniper Lane. You know, if you want to head east towards Brookside Lane and go over the bridge. And the north leg is going to be a one-way out operation to allow traffic out of Juniper Lane heading on to Route 89. And then, you know, as I mentioned previously in the presentation, out there today, we've got widths that are 14 to 16 feet roadway width on both of the legs. We're going to be narrowing those up to 12 feet. And again, that's just to limit our impacts to, you know, adjacent right of way, as well as to accommodate our retaining walls and provide for, you know, this 3.5 to 4 foot fill that we need to accommodate to improve our vertical geometry for both of the legs of the intersection. Jeff, you got anything that you want to add, or?
No, I think you hit everything. You know, one of the things that you don't really see if you're talking about widths of roadway is what happens off the roadway. So if we needed an 18-foot wide roadway, we actually need more because we need flatter shelves on the side of the road in order to get our guide rail in. So when we talk about widening an existing road to accommodate two-way traffic, it's not just widening the pavement. There's other things off the pavement that would require us to widen even further to get our roadside safety elements in there, like guide rail. There's a ditch on the inside of that Y that we're creating to manage drainage coming off of Route 89. So there's a lot of things that would be spread out even further if we were to try to maintain bidirectional traffic. And as Tom mentioned, right-of-way is definitely one of the major impactors. The right-of-way is very close to the existing edge of road, particularly on the south leg. And the retaining walls would likely have to be extended at least 3/4 of the way up both of those Ys if we were to try to maintain two-way traffic. And that, of course, limits, you know, I guess, sight to the surrounding environment. So you kind of close it in once you put, you know, these long walls in there. So this is, I think, more aesthetically pleasing to kind of keep it a narrower roadway. And we still accommodate, you know, managing the traffic efficiently.
Thank you, Jeff. Andrew said thank you. He appreciates the answers and understands that it's complicated. He did ask if he could get a transcript of the questions and answers.
So we're going to be putting together a report of meeting, and this presentation will also be eventually uploaded to the project website. So Andrew will be able to provide you that hopefully in the next couple of weeks after the comment period for this job has completed on October 29th.
Right.
Thank you. Appreciate that.
Right. Kurt said, I'm assuming that the new bridge will accommodate the largest of the emergency vehicles, i.e. fire trucks.
So we've run templates for the larger tanker truck. And so it does accommodate that. Yes, we didn't run it for an aerial truck or a ladder truck because we don't see that there's a need for that down in that area. But yes, that's been accounted for.
We'll leave this open for another minute for questions. I am going to pop up our survey into the chat. It is a volunteer survey, but it does help us with future presentations. Again, the project webpage is in the chat as well, and that is where we will be posting our reading of minutes like Tom was discussing earlier, and that's where you'll be able to find a recording of tonight's meeting if you'd like to come back and reference any of the things we discussed tonight. And our comment period is open through October 29th, and you can email your questions until that date by email at dot-flbp@ct.gov or by phone, leaving us a voicemail at 860-594-2020. Thanks so much, Andrew. Have a great night. Okay, seeing no more questions, we are going to close up tonight's virtual public info meeting. Thank you all for your great questions and for coming to this presentation. I hope you have a great week. Take care.
Thank you.